So this is going to be limits at infinity. Okay, what a limit at infinity means is what happens, what's the y value of the graph going to be as the numbers get bigger or smaller? There are two types of limits at infinity. One is called a divergent. Okay. An example of a divergent limit means as x goes towards infinity, y goes to infinity as well. Okay, so it doesn't actually go to a number. You've seen many graphs like this. The example would be like y equals x. It would be one like that. Okay. That's a boring limit. Okay, right? But if you were to put f of x equals x, you plug in infinity, the answer is going to be infinity. The ones that are more exciting for us, what we call convergent limits. Okay. This would be as x approaches infinity, y goes to k, where k is a real number. Okay, and that's what we're talking more about today. So as a graph goes on to infinity. Now, limits at infinity is what has caused many mental mathematical problems over the years. Okay, it's like when people ask this. Are you ready for this mathematical question for yourself? Here we go. What's the answer to 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1? Are you sure? Wouldn't it equal 1 possibly? Wouldn't it equal 1 half? What's it possible? Because it depends what the ending value is, right? If the ending value is a negative 1, then it's going to equal 0. What if the ending value is 1? Well, then it's going to equal 1, right? So mathematicians are, because that's one of the difficulties there, okay? The same thing for convergent and divergent. You've probably seen this before. If you look at the area of a box, okay, and that has size 1, you cut it in half, that's 0.5. So this is the series I'm trying to get you to do. This would be an example of a convergent series there, okay? Because if you look at how we're going to do here, we're just going to be adding up areas smaller and smaller and smaller each time. What does it look like that area is going to add up to? It looks to me like it's going to add up to 2. Okay, that's what it looks like it's going to be. Okay, but you can see because I'm always adding smaller and smaller and smaller pieces, you're always going to miss by a little bit. But that's the power of infinity. If we could get infinitely small, you would end up with a value of 2. So that would be that convergent limit would converge to a value of 2. Okay, for that. Okay. Let's get into how this affects us in this course, which is infinity algebra. And I can't remember if I did this last year in grade 11 or not. You may have seen this before in advanced functions. Okay. So here we go. Let's start with a few things that are necessary for infinity algebra. Anyone want to guess what 0 plus means? You may have been, if you're in Mr. Lacey's class, seen this before. Amy. Good, very good. Okay. So if you want a number, it would be like right? So it's like a very, very small number, a little bit bigger than 0, but it's positive. Okay. In the same way, then 0 negative would approach 0 from the negative side. Which is negative 0.0000000. Okay, so just a little bit less. You're probably going to say to yourself, Mr. Sadler, why does this matter in the least? I will show you right now. Okay, I'll show you right now. And you've seen this all before when we graphed the graph of 1 over x. How does the graph of 1 over x look? Yeah, it's 1 over x squared, that one. Oh, yeah, well, you did it like this, yeah. So the graph of 1 over x looks something like this. There's a beautiful top point. And there's a beautiful bottom point. Okay? So this is a perfect example of the divergent series here, the convergent series. Okay, so we're going to say here, the limit of this graph as x approaches 0 from the plus of 1 over x. Okay, because that's what we're looking for here. From the graph, we'll worry about the limits for a second, the algebra. What's the value going to be as you get just to the right of 0? What's y going to equal? Infinity. Okay. Okay, and that brings us to our rule that any value over positive is going to be positive infinity. The same way on the right-hand side, if I go limit a little bit smaller than x, what's that going to equal way down here? Negative infinity, very good. I should probably change to say that a has to be greater than 0. And the same thing over here, a over 0 minus. Or a has to be less. You're feeling so far so good. Martin, how are you feeling? We're okay so far? Yes? Okay. Excuse me. The same thing here. If we're looking for the limit as x approaches infinity of this, I'm going to use my stay on the same page if I can. If I go to the limit of x approaches infinity from 1 over x, okay. 1 over x is going to be 1 over infinity. What does 1 over infinity equal? 0. And if you don't believe me, think of it this way. 1 divided by 10 billion, jillion, quadrillion, gazillion, chameleon. Okay, that's basically what a billion is. So that's what infinity is, okay? You have almost nothing left. If you want to call it 0 plus, if that makes you feel better, go ahead. Okay, because it is technically above that. The same thing if I go to the limit as x approaches negative infinity, 1 over x equal to 1 over negative infinity. Equal to 0 minus. So I'll summarize those for you in red here. Okay, so we're going to say that 1 over infinity is equal to 0 plus 1 over negative infinity is equal to 0 minus. Summarize it. Okay, the last one I want to talk about, 0 over 0, infinity over infinity. What's the answer to 0 over 0? What does 0 over 0 equal? Michael, do not share the answer to the class. Mike is correct, though. Error. 0 over 0 equals start over. It means you made a mistake. Okay, the reason for that, let's say that I told you that 0 over 0 is equal to 1 or something like that. Okay? Algebraically, that's not going to work for us, okay? Okay, so stick with that. We're not going to do the same thing. Infinity over infinity is going to equal what, please? Some other Michael? No. Infinity is going to be start over. Okay? We don't actually have a value because infinity could be any number, so we don't want to stick with it. In the same way, what does infinity plus 1 equal? It's still equal to infinity. Okay? What does infinity times k equal? Infinity. Don't remember when you guys were kids, they never said this. I hate you, infinity plus 1. Oh yeah, well I hate you, infinity times 1,000,000. Okay, that's all still infinity. Okay, I hope you guys didn't have geek wars like I did when I was a kid. I had fights with people like that. Okay. Finally, then the same way, if I like to do like infinity minus 10, what's infinity minus 10 going to equal? Infinity. What's infinity minus 100,000,000 going to equal? Still equal infinity. Okay, the scope of it is so big. If you add or subtract anything to it, it's still going to be infinity. The same thing with multiplying, the same thing with raising to a power, anything like that, it's still going to be infinity. Okay, which is where people have problems with a few things. Okay, let's do some infinity math now, shall we? We'll pick a question like this. So, to evaluate infinity limits, divide by the highest power bracket oblique asymptotes, because this is the way that you dealt with oblique asymptotes in advanced functions. So example 1 is going to say a limit of x approaches infinity, 2x squared negative 4x plus 3 all over 3x squared minus 8x plus 2. Okay, that's like a vicious, awesome equation to graph, okay, and there's so much going on there, okay? We'll deal with the limit as it goes to infinity, because when we graph this, we're not going to graph this today, okay, but when we have to graph this, finding out its value, like its trending value on the right or the left is sort of a big deal, okay? Okay, so let's just say evaluate, let's say I substitute in x equals infinity. You get infinity, 2 times infinity squared minus 4 times infinity plus 3 all over 3 times infinity squared minus 8 times infinity plus 2. Yeah? Okay, infinity squared is still infinity. Infinity minus infinity is, we don't know, plus 3, I'm going to call that infinity over infinity, which is start over. Okay. The problem is you can't do like, okay, I should also have said this, infinity minus infinity equals start over. Okay, because you can't compare it, like you can't say, well, because there's all these problems with infinity, so let's say that Nate likes me infinity plus 1, and I only like him infinity. Like you would when you subtract our likeness for each other, would you say the answer is 1? Well, in that case it is, because you're treating it like a variable, but infinity minus 1 we said is already infinity, so it's hard to deal with. So just deal with the start over. The rule is for infinities, when you try to compare them, basically you're having problems, okay? So you don't want to have to compare infinities, it doesn't work. At least in grade 12 it doesn't. So what are we going to do is the question then. How are we going to deal with this? Is it just equal to start over? I don't know the answer is when x is 10 billion. What do I do? Yeah. Yeah, we could. Yeah, they will cancel out. Okay, we're not going to factor though. What we're going to do is we're going to divide each term by x squared. Okay, so this should go from the last semester, it should, I hope. Right, so the limit, maybe you didn't call it as limits though. So it's 2x squared over x squared minus 4x over x squared plus 3 over x squared, I guess, divided by 3x squared over x squared minus 8x over x squared plus 2 over x squared. Okay, why does that help me? What's that going to do for me? Nobody knows that. You guys want to cancel out all the x squares. The thing is we can divide by infinity and not have a problem. So I'm sort of cheating here. Okay, because it's okay to divide by infinity, so I can deal with 8 divided by infinity and numbers like that, but I can't deal with that. So this is going to turn into the lim as x approaches infinity of 2 minus 4 over x plus 3 over x squared all over 3 minus 8, minus 8 over x plus 2 over x squared. Questions, fears, and puzzles yet? Sorry, I know I'm going quickly, I apologize. Okay, great. I'm going to try and evaluate right now. Liam, I'm picking on you. If we evaluate inference value, tell me what to write, please. Yeah, that is what it's going to turn into, yes. Go right to the point. I'm going to show my work, though. Because we said infinity squared is just infinity, okay, so 4 over infinity is 0, right, and then 3 over infinity is 0, so this is going to be 2 minus 0, sorry, plus 0, all over 3 minus 0 plus 0, which equals 2/3. And you guys probably did something similar to this. Maybe not. You guys doing behavior like this last year? Yeah. Would you? Maybe? Okay. Yeah, and all that sort of stuff. This looks somewhat familiar. You can sort of handle the idea of this. Okay. It's possible to have an answer of infinity. I don't mind. That would be the divergent limit, okay? So let's say, I'm going to give you guys a second to try this one out for me. I'm going to say evaluate, we'll go for 2 or 3, I can do 2. 2. That's one where the highest degree of the numerator is different from the denominator. You can read my mind almost. X to the 18, 3x 17 plus 1. Now don't be afraid. You guys are like, oh my goodness, x to the 18, what's up? What's up?